Hello everyone, I'm Vivek Kaithwas. Welcome to my channel. I'm pursuing MTech from IIPS GAVV Indore. In today's video, we will be discussing about assignment of subject Introduction to Data Science and R Language. I hope you have seen my previous video and stay tuned for more amazing videos in future. Now, let's start the video. So here question 1 we have explain the difference between supervised and unsupervised learning. Provide example of algorithm for each type of learning and discuss scenarios where each would be appropriately used. So features we have definition. So in supervised learning, it is a type of machine learning where the model is trained on a labeled data set. That means input data is provided along with the correct output. Now unsupervised learning, it is the type of machine learning where the model is trained on unlabeled data and the system tries to find patterns or structure on its own. Now data learning, data requirement for supervised learning requires labeled data input or output pairs, and data requirement for unsupervised learning is works with unlabeled data, only input, no output labels. Now goal for supervised learning is to predict outcomes or map inputs to specific outputs, to discover hidden pattern structures or relationships in data. Type of learning. In supervised guided learning, since data has known answers, and in unsupervised learning, self-learning, no predefined answers. Output of supervised learning produces predicted results, example, classification, labels, or continuous values, and output of unsupervised learning is produces clusters or associations showing data patterns. Now, common algorithms in supervised learnings are linear regression, logistic regression, decision tree, random forest support vector machine, SVM, K nearest neighbors, KNN neural networks, and in unsupervised we have K means clustering, hierarchical clustering, database scan, principal component analysis (PCA), a priori algorithm, auto encoders, and evolution metric in supervised learning, accuracy, precision, recall, F1 score, RMSE, etc. and evaluation evaluation metric in unsupervised learning is Silhouette score, Davis Baldwin index, or visual inspection. Now, example use cases: email spam detection, spam or not spam, credit card fraud detection, disease diagnosis, stock price prediction, sentiment analysis come under supervised learning, and customer segmentation, market basket analysis, and anomaly detection, document clustering, and image comparison comes in unsupervised learning. Now, need for human intervention requires labeled data, hence more human effort in data preparation. In supervised learning and less labeling effort, model explores pattern. Less labeling effort, model explores patterns automatically. Less labeling efforts, model ex, less labeling effort, model explores patterns automatically. Now, third we have output type, predictive help in future prediction, and descriptive help in understanding data structures. Now describe the concept of hypothesis space in machine learning. Explain the algorithm find S. Find a hypothesis by find S for the following instance in a training set. So here is the table we have, and now hypothesis space concept. Now hypothesis space return H in the set of all candidate models hypothesis that your learning algorithm can choose from or to explain the data. It depends on how you represent hypothesis. Example, all linear functions, all decision trees up to the depth 3, all conjugations of attribute value or tests. And choosing H is choosing an inductive bias. It limits what you can learn. You can only learn concepts that have a representation in H, but also makes learning feasible. Two important ideas. Most specific hypothesis, example, null for every attribute and matches nothing except exactly specified values, and most general hypothesis often return for every attribute matches everything. Now the version space is the subset of H consistent with observed training examples, algorithms like find S, explore H, or move in it. Now it to find a consistent hypothesis. Now find S algorithm, short or precise. Find S is a simple algorithm for learning conjugative hypothesis, that is hypotheses that are conjugation of attribute value tests when attributes are categorical or treated as atomic values. Pseudocode classic. Input training set of example X or label attribute A1 to AK. Now initialize H, most specific hypothesis HI equals to uh, phi for all I. Now for each positive example X, for each attribute I, if HI equals to phi, set HI equals to XI. And else if HI is not equals to XI, set HI equals to question. Minimally generalize. Now else leave HI unchanged. Ignore negative examples. Find S does not use them except to check consistency. Output is H. Now here phi equals to most specific, no value yet, and uh, question mark equals to wildcard except any value for that attribute. Now complexity is O hashtag example into hashtag attributes. Limitation finds the most specific hypothesis in H consistent with positive values only. If ignores negative examples and will fail if no consistent conjugative hypothesis exists. Now, run finders on the dataset step by step. We treat hypothesis H as a 5 tuple in attribute order, color, origin, manufacturer, decade, and type. Now, initialize H equals to 5 phi, most specific. Now, example 1, Blue Japan Honda 1980 economy positive. So, H becomes Blue Japan Honda 1980 economy. And now, example 2, Green Japan Toyota 1970 and sports. So, here it is negative. So, find S ignores negative and H remains unchanged. So blue Japan Honda 1980 and economic. Now example 3 blue Japan Toyota 1990 economy positive. Compared to current H color blue versus blue. So keep blue and origin Japan versus Japan keep Japan. Manufacturer Toyota versus Honda different. So generalized to question mark. Now decade 1990 versus 1980 different. So generalized to question mark. Now type economy versus economy. So keep economy. So H becomes blue Japan question mark economy. Now example 4 red USA's Chrysler 1980 economy negative. So ignored and H remains unchanged. So here H is blue Japan question mark economy. Now example 5 white Japan Honda 1980 and economy positive. So compared to current H color white versus blue different. So generalized blue to question mark. Now origin Japan versus Japan keep Japan and now manufacturer Honda versus question mark stays question mark and decade 1980 versus question mark stays question mark and type economy versus economy keep economy. Now final H becomes question mark Japan question mark economy. Final H found by find H in readable form H color is question mark any color and origin Japan manufacturer question mark any manufacturer decade question mark any decade type economy or as a conjunction if origin equals to Japan and type equals to economy then positive else negative according to this hypothesis. This hypothesis correctly classifies the three positive examples in the training set and it assigns negative to example to sports and origin equals to USA consistent with the training levels. Question number 3. Explain the purpose of training tests and validation sets in machine learning. What is a cross validation? How does it differ from a simple train validation test split? Purpose of training validation and test sets. Set type training set. Purpose is to train the model. The model learns the relationship between input features and output levels. Used for model learning fitting parameters. Example scenario. The model learns the higher square footage, higher house price. Now validation set. To tune hyperparameters and evaluate model performance during training without touching the test data. And used for model tuning and selection. And example scenario for validation set used to decide which learning rate or number of layers gives the best accuracy. Now test set to evaluate the final model performance after all tuning is done. It measures how well the model generalized to unseen data. Final unbiased performance evaluation and checking how the chosen model performs on completely new house data. Now example data split. If you have 100% of data, then 70% to training set and 15% to validation set and 15% to test set. Now, what is cross validation? Cross validation is more reliable technique to evaluate model performance compared to a single train validation test split. It ensures that the model's performance is consistent across different subsets of the data aspect, data division, simple training validation test split, and cross validation example k-fold CV. Now, aspects are data division. So, data divided once into fixed train and validation and test sets in simple train validation test split, and data divided into k subsets, each subset used once for a validation in k-fold cross validation, and stability of results. in simple train validation can vary depending on how data was split, and in cross validation, more stable and reliable uses all data for training and validations. Now, computational cost in simple train validation is low, train model once, and higher in cross validation as model trained k times. Now, use case useful when data is large and training is time consuming, and cross validation are useful when data is small and you want to robust evaluation. Output metric. Single validation score in simple train validation and average of k validation scores reduces variance in cross validation. Question number 4. Given the confusion matrix, find classification, accuracy, precision, recall, type 1 error, type 2 error, F1 score, sensitivity, specificity. Explain the importance of precision recall as compared to accuracy with an example. So here is the confusion matrix given, which has true positive 6, false negative 2, and 4 as false positive and true negative 8. Now here is the description. Uh, Classification accuracy. So accuracy formula we have is TP plus TN divided by TP plus TN plus FP plus FN. Now putting the values, we here got 14 by 20, which is 0.7, and accuracy equals to 70%. Now for precision, we have formula TP upon TP plus FP. So precision equals to 6 upon 6 plus 4, which is 6 by 10, and which gives 0.6, which is 60%. Now recall, sensitivity or true positive rate. So recall is here is TP upon TP plus FN. So recall equals to 6 upon 6 plus 2, which gives us 6 by 8, which further gives us 0.75, which is 75%. Type 1 error, false positive rate. So type 1 error formula is FP upon FP plus TN. So by putting the values, we got 4 by 12, which gives 0.33, which is 33.3%. Type 2 error, false negative rate. So false negative rate is Fn upon Fn plus Tp. So type 2, by putting the values, we got 2 by 8, which is 0.25, and which is 25%. F1 score. F1 equals to 2 into precision into recall upon precision plus recall. So by putting the values, we got 0.45 divided, we got 0.667 equals to 66.7. Now sensitivity, same as recall, which is Tp upon Tp plus Fn, which we got here is 75%. Now specificity, true negative rate. So specificity formula is Tn upon Tn plus Fp. Now specificity, by putting values, we got 0.667, which is 66.7%. Now, conceptual explanation. Importance of precision and recall versus accuracy. Accuracy alone can misleading when data is imbalanced. That means one class is much larger than the other. Example, imagine a medical test for detecting a rare disease. Out of 1,000 people, only 10 are actually sick. Model predicts everyone is healthy. It gets 990 upon 100. So correct accuracy is 99%, but recall is 0%. Missed all 6 people. Now, precision tells how reliable positive predictions are. High precision equals to few false alarms, important in spam filters and fraud detection. Recall. Recall tells how the comprehensive the model is in catching positives. High recall equals to make few missed positive, important in medical diagnosis, safety critical tasks. Question number 5. Discuss the importance of dimensionality reduction in machine learning. Compare and contrast feature extraction and feature selection as two approach to dimensionality reduction, and provide example of techniques used for each approach. Why dimensionality reduction is important? Reasons: reducing overfitting, and because fewer features means the model focuses on relevant information, reducing the risk of memorizing noise. Improve model performance. Models train faster and generalize better with less irrelevant or redundant data. Saves computation time. Lower dimensional data requires less processing power and memory. Now enhances visualization. Help visualize high dimensional data in 2D or 3D, example PCA plots. Now removes multi-collinearity. Eliminates correlated or redundant features that can distort model interpretation. Now two main approaches to dissimilarity reduction. First is feature selection and feature extraction. Now definition of feature selection is selecting a subset of the most relevant feature from the original dataset without changing them, and feature selection is transforming the original feature into a new, and feature extraction is transforming the original feature into a new set of features, combinations of old ones. Now goal of feature selection is keep only the most useful existing features, and goal of feature extraction is create new informative features that capture most data variance. Type of process in feature selection is filtering or choosing features, and type of process in feature extraction is transforming feature mathematically. Output features: original features subset, new features transform or combined. Interpretability: easy to interpret, features remain the same, harder to interpret, and features becomes abstract or lenient in feature extraction. Now example techniques in feature selection. Filter methods, correlation, chi-square test, ANOVA, wrapper methods, recursive feature elimination RFE, embedded method, lasso, L1 regularization, decision tree feature importance, principal component analysis PCA, linear discriminant analysis LDA, TSNE, redistributed stochastic neighbor embedding, autoencoders, neural networks. Now, use cases example, removing irrelevant columns from a customer data set, example, IDO timestamp. In feature selection and in feature extraction, comparison, compressing image data into a key principal component for facial recognition. Now, question number 6, define overfitting and underfitting in the context of machine learning models. Describe how these issues can be identified and list strategies to prevent or mitigate them. Now, overfitting. The model learns the training data too well, including noise. It performs very well on training data but poorly on test data. How to identify high training accuracy but low test accuracy? Ways to prevent: use more training data, use regular use regularization like L1 or L2, use similar models, use dropout in neural networks, use cross validations. Now the underfitting. The model is too simple and fails to learn patterns. It performs poorly on both training and test data. So how to identify low training accuracy and low test accuracy? Ways to prevent: use a more complex model, train or more epochs, and add more useful features, reduce regularization. Now question number 7. Differentiate logistic regression and linear regression on basis of hypothesis, parameters and cost functions. How gradient descent algorithm is used to optimize the parameter. Now linear regression and logistic regression. So hypothesis function in linear regression is h theta x equals to theta t x, product's continuous output, and h theta x equals to 1 by 1 plus inverse theta t x, sigmoid function output between 0 and 1 in logistic regression. And type of problem in linear regression used for regression problems predict numeric values, and type of problem in logistic regression used for classification problems predict class levels. Now output in linear regression: real numbers, example price and temperature. Output in logistic regression: probability of belonging to a class, example spam or not spam. Parameters: weights theta 0, theta 1, theta n in linear regression, and same weight but interpreted as affecting probability. Now cost function, we have formula for linear regression is this, and for logistic regression we have formula is this. Now decision boundary: a straight line in linear regression and a curve determined by sigmoid and threshold in logistic regression. Now range of hypothesis in linear regression it is minus infinity to plus infinity, and in logistic regression it is 0 to 1. How gradient descent optimize the parameters? Gradient descent updates parameter 0 to minimize the cost function. Now here we have formula theta equals to theta minus alpha delta j theta divided by delta theta, where a is learning rate, delta j theta upon delta theta equals to slope indicating direction on improvement. The algorithm repeats steps until the cost becomes minimum. Question number 8. Write a program in Python to implement logistic regression and linear regression. For every method, compute and display the implemented model evaluation measures which is applicable, such as accuracy and other values of different evaluation metrics such as confusion matrix, accuracy, precision, recall, F1 score, specificity, and loss function, RMSE and R2 square. Now, here in Python code, we have first linear and logistic regression. So import numpy as np, then from skill learn model selection import train test split and other libraries, and then we have data lr equals to log uh, diabetes, and xlr and ylr equals to data lr dot data and data lr dot target. It is the constructor. And now we have other parameters: xtrain, xtest, x ytrain, ytest. And now for model r, linear regression equals to linear regression function and model lr dot fit x train and y train. So pred lr equals to model lr dot predict x test. Now print linear and then this, and now print linear regression evaluation, print RMSE and print R2 score and R2 score. Now it is the further code for logistic regression, and by from this code we got this output: linear regression RMSE, R2 score, and logistic regression confusion matrix, accuracy, precision, recall, F1 score, and specificity. Now question number 9. Write one hot encoding for the given data. So here is the given table, and we have to write one hot encoding on this table. So One hot encoding explanation. One hot encoding converts categorical values like apple, mango, or orange into a binary column 0 or 1. One common for each category. Each row has 1 in the column representing as category and 0 elsewhere. So for the fruit column, apple is 100, mango 010, and orange 001. So here we got the table. In fruit column we got 1010, fruit mango we got 0100, and fruit orange we got 0001. Value of fruit are in first we have 1 and price is 5, and value of fruit in second row we have 2 and price is 10. Now third row we have 1 and value of fruit is 1 and price is 15, and fourth row value of fruit is 3 and which is in fruit orange and price is 10. Now, why KNN is considered as lazy learning? Discuss K nearest neighbors. Consider the following table. It consists of the height, age, and weight. Target value of 10 people. The weight value of ID 11 is missing. Predict the weight of this person based on their height and age. So, here is the given table. And now, why KNN is called lazy learning? So, lazy equals to the algorithm does not almost no training, no explicit and model building. At training time, it simply stores the training data. All the work happens at prediction time to classify or predict a new point. It searches or training set for the nearest neighbors and uses their label values. Contrast, eager learners like linear regression and decision tree build a model parameters at training time and then predict quickly. Consequences. Pros, very simple, flexible, adapts to complex decision boundaries, naturally handles multi-model classes. Cons, prediction can be slow, searching whole dataset, memory heavy, sensitive to irrelevant features, and feature scaling. Choice of K matters. Now K nearest neighbors, short decision. Type, task types, classification, majority vote of neighbor or regression, average weighted average of neighbor values, distance matrix, commonly Euclidean for numeric features but can use Manhattan-Minkowski and domain-specific distances. Feature scaling, crucial. Features with a large numeric range dominate distance, always standardize or normalize z-score or min-max when features have different scale, age versus height here. Choice of K, small k, low bias, high variance, sensitive to noise, large k, smoother bias predictions, typical odd small values 3, 5, 7 are common starting points. Weighted KNN, weight neighbors by inverse distance, so closer neighbors influence prediction more. Predicting weight for ID 11. Height is 5.50 and age is 38. I used a KNN regression with Euclidean distance and standardized features z-scored so height and age contribute. Comparably, I show results for a few common k-choice nearest neighbors after standardizing. The nearest training points to ID 11 ordered by distances are ID 10, which has weight 58 and 5.60 and 32 age, and ID6 which have height 5.80 and 36 weight age and weight equals to 60, and ID3 which have height 5.60 and age 30, weight equals to 55, and ID4 which have 5.90 is height and 34 age and weight equals to 59, and ID8 which have 5.80 height and 28 age and weight is 60. Others follow. Predictions. K equals to 1, nearest neighbor ID 10, prediction 58. Now K equals to 3, ID 10, 6, 3, prediction mean 58, 60, 55, which gives 57.67, which is approximately 57.7, and K equals to 5, which gives 58.4, and K 3 weighted K equals to 3, weight equals to 1 by distance. So weighted average equals to 57.86. So recommendations, a sensible prediction, balanced common choice is K equals to 3. So predicted weight equals to approximately 57.7 units, same as given weights. Now, thank you for watching this video. Please do like and subscribe and share. And I hope this video might be helpful to you. Please stay tuned for more interesting videos. And thank you for your